Continue our lecture on Chapter 4. This is Part 3 and should be the final part. There will also be 2 demos of Auction and Music Organizer that you'll be able to look at separately, as well as an overview of Assignment 3. Main concepts to be covered: the difference between definite and indefinite unbounded iteration, loops using the while loop. Search tasks are indefinite. In other words, you're going to go until you don't need to go anymore, and then you're going to stop unless you run out of things to go through. Searching for your keys, as an example, you ever notice that your keys are always in the last place you look when you find them? You can't predict in how many places you're going to have to look in advance. There may well be an absolute limit. In other words, there's only so many places in your house you can hide your keys. Although having lost my keys before, I would argue with that. You will stop when you find them, and indefinite loops are also possible, which we'll talk about. The for each loop repeats the loop body for every object in a collection as a rule. Sometimes we require more flexibility. Sometimes you want to exit out of the loop and you want to exit gracefully. The ways to break the for each are not graceful and generally should be avoided. We use a Boolean condition to decide whether or not to keep iterating. It's a very flexible approach and not tied directly to collections. In other words, the while loop is a general use thing, not a collection use thing, although it can be used with collections. While some condition, continue to loop. So what it's going to do is start with this, end with this, everything in the middle. It's going to keep running over and over and over again while we wish to continue to do the things in loop bodies. So once this condition becomes false, it'll automatically exit. While the keys are missing, look in the next place. Or while not, the keys have been found. Be careful about using a not. People do use it. It's not wrong, but if you're not careful in your coding, you'll be confusing and actually cause problems. So to codify what we just had, we have a Boolean named searching. While searching, if they are in the next place, searching equal false. So in other words, once you find them, drop out. Suppose you don't find them, what would happen? You'll be stuck in an infinite loop. Index, so while we're less than the files.size, in other words, remember that file collection that we had from earlier. While we're less than the total number of elements, continue to iterate and allow the index to increase by 1. While the index value is less than the size of the collection, we're going to continue to get the next things, what I just said. Hopefully that's straightforward. We have declared an index variable. Conditions must be expressed. We have to fetch each element. In other words, we have to get it from the collection on our own manually versus having it automatically done, which is what the for each does. As well as the index variable must be incremented explicitly, where for the for each you don't need to do that. So, easier to write, guaranteed to stop. A little bit harder to write, but you can exit more gracefully if you want to. But if you create an infinite loop, in other words, you don't ever set your while to false, you'll continue to running in that and it'll lock up your system. A fundamental activity applicable on all collections, necessarily indefinite. We must code for both success and failure, nowhere else to look, etc. If you use the for each, you end up going through the entire collection every time. But if your collection is guaranteed to be unique, then the for each would potentially have you do extra work that you don't need to do. How do you finish a search? You reach the end of the list by your indexes being greater than. You set some value to true to cause an exit. Very often you have to combine them together, as they're demonstrating here. So while the index is less than the size and you haven't found it, or while the index is less than the total number and you're still searching. Be careful about that though, because depending on how you write this, you might need an or an and as you flip the logic. In this case, they're both ands, but you could do, you could revise this if you took the negative of it. Okay? Searching collection, in this approach they're doing searching equal true. They've added it to the index, so this way we're a little more specific. Once it's found, we exit out. Otherwise, we continue to increment the exit index. Another alternative, if you haven't found it, while it's not found, set found equal to true. Same exact concept, just a slightly different way. The exclamation mark means not. I actually like that one, if not, and not found. But again, reading it, people might miss it, make a mistake, whatever. So it's easier to always code in positives. Does the search still work if the collection is empty? It would, because of this. If the index, which starts at 0, if there's not any items in there, the file size wouldn't be, or would be 0, so it would automatically drop through right there. While the body can be executed 0 more times. Okay? Side note, string class has some special features. In particular, comparison of string objects can be tricky. The compiler merges identical string literals in the program code. The result is a reference equality for parent distinct string objects, but this cannot be done for identical string objects that arise outside the program's code. In other words, pay attention to when you work with strings and string literals. They don't always work the way you think they should. There's better ways to do it that we'll talk about later on. Input == quote by doesn't work. This does work. Remember, this gets turned into a memory address, and it's saying, is this memory address the same as that memory address? Which is not what you meant. You want .= quote by. If you write the code and you put it in a compiler, you'll actually see that happen. All right. Here's a little more demonstration. Person 1, person 2. Does person 1 == person 2? In other words, does this pointer equal this pointer is what you're saying. In this case, what would I get? Would it be true or false? Still be false. Now, this case, it would be true because person 2 is pointing to the same place as person 1. So the value of the pointer is correct. Okay? String, let's see, identity versus equality. Get input, input ==. What is this going to give you? You know, we've already talked about it. Because the memory addresses are not the same. Okay? What will this one give you? True, because the value inside a string is equal to the value inside of input. Okay? While without a collection, here's another example of using the while statement. They have the index seated at 2, meaning initial value. It's going to continue to run while index is less than or equal to, and it's going to skip. So it's going to go up by evens. Okay? Moving away from string, our collection of string objects for music tracks is limited. We want more stuff in there, so how could we possibly do it? Something to think about, and we'll come back to it later. So the iterator and the iterator class in the method, it's expressed this way. This is just informational slide. Iterator less than greater than E, meaning that this can be a class. You've got different capabilities within here. That's all that's trying to show you. Java.util iterator, iterator element type, IT, blah, blah, blah. In other words, you have a collection. You set the collection into here. The iterator gets it, and now you can iterate on it. And an iterator has a hasNext function, which is really nice. Talk about it up here. Okay? So what this is going to do is while there's something more in the loop, continue to run. Every time you call hasNext, it moves it into IT. Track tk equals it.next. System.out.println the details. So in other words, what this does is it advances the pointer for you. Okay? There's a demo coming up of it. So we're starting out. Mindless iterator. It's automatically starting there. hasNext. Grabs the item. Says yes there is. And it moves it forward. Now it pops this down for your use to go through it. And again, each time it has next, it keeps going through it until it reaches the end. Alright, so the pointer's moved. Now hasNext says, nope, there's nothing left. So your loop would exit. Okay? Index versus iterator. Each one has their own merit. Each one has value. Ways to iterate over a collection. For each loop, it'll process every element. While loop will stop partway through. An iterator, if we want to use if we might want to stop partway through, much like the while. Often used with collection where index access is not as efficient as it could be, or if you need to remove items from a collection. All right, and we'll talk about that in a second. This is a very important programming pattern. It is something that I do use and I use often. Alright, so here's an example of what would happen. IT hasNext, we just talked about that. It's going to iterate through it. Once you execute has next, IT has the current item, IT gets moved into track, we get the artist, if they equal, then remove it. If I'm going to iterate all the way through this, it'll go through all of them in case that artist is there multiple times with the same name. Now, removing from a collection. Alright, so what happens here? If we have an index and track size, let's say there's 5 things in there. It does the same thing we just talked about, does the same thing we just talked about. We actually found it and we removed it. So now we're on item 2. This index is increased to item 3. But the problem is when you did the remove, item 3 is now in the 2 position, so you actually will have missed one and continue to go. Okay? Loop statements allow a block of statements to be repeated. For each loop does that. While loop, repetition can be controlled, and with an iteration you can control as well. The auction project, I'll go through in a little bit. It'll give some examples of this, and we'll come back to it. Examples of using null, anonymous objects, and chaining methods are all shown in there, and I'll make sure I'll go through them with you. The null object, remember that the null object is a class that has nothing, or an object specifically, that has no information. So it's there, but it hasn't got anything. You can actually check to see if it's equal to null. Examples will happen in future examples of code. Anonymous objects, we've talked about that. Objects are often created and handled elsewhere immediately. Further lot, new lot, lots.add. We don't really know further lot. We don't know anything about it, but it's more generically implemented. Chaining methods, you can absolutely do that. I actually try to avoid this because it makes code harder to read and maintain and debug. But in this case, get highest bid populates bid, then get who did the bidding gets put into bidder. So now to save some work, you could have just done lot.getHighestBid.getBidder. So this is going to act on the class bid, and this operates on the class lot. So these are just examples of a way to approach that. I'm not a terribly big fan of this. It is more efficient in terms of keystrokes, but in terms of debugging, when you get some of these really long ones, you'll find it's really a pain. The flip side is when this is 5 or 6 deep, you don't want to have a bunch of artificial code just to be able to get to a particular value. This is what I just explained. Take a moment, pause the video if you need to get an understanding of it again, but it is what I just walked through a few moments ago. To review what we've done now, collections are used widely in many different applications. Java library provides many different ready-made collection classes. There's hash, there's array, etc. They're all very good. Collections are often manipulated using iterative control structures. The while loop is the most important control structure to master. People will debate with you on this one, so we'll just take it. Some collections lend themselves to index-based access. ArrayList is an example. Iterator provides an versatile means to iterate over different types of collections, which is very helpful, and it has removal. I'll tell you, Iterator is very, very nice. With that, that's the end of this discussion. If you have any questions, as always, please do not hesitate to email me. Hopefully this lecture was useful and you got something beneficial out of it. Thank you.